Good evening, science students. Today what we're learning about in chemistry is types of chemical reactions. There's 5 types that we're going to learn about, and you need to know all 5. So let's take some notes and write this down. We have synthesis, which we're going to equate to marriage. That's our analogy, which helps us remember that. Decomposition, which we're going to use the analogy of divorce to help us remember that. Single displacement, which we'll talk a little bit more about. Double displacement, and combustion, which you should recognize as fire. So synthesis means to make something, decomposition is breaking down something, single displacement is replacing one thing, double displacement is replacing 2 things, and combustion is burning things. Let's start our lesson now. Okay, so the first type of reaction that we're going to talk about is synthesis, which I said the analogy was marriage. Why is that? Well, it's because you're putting 2 separate things together. This means that you're going to have 2 reactants and you're generally going to form just one product. Okay, so atoms combine together to make larger molecules. So you have one atom or separate thing and you're adding it to another atom that's smaller and you're combining them together to make something larger. In general, we write it as A plus B equals AB. A chemical reaction example would be nitrogen plus hydrogen equals ammonia. How many reactants do we have here? Well, there's 2 reactants and 1 product. So 2 reactants, 1 product. We're forming one thing out of 2 things. That's it. Also remind you guys, again, this is a skeleton reaction. What does that mean? It means it's unbalanced. How many nitrogens? 2 nitrogens here, 1 nitrogen here. You have to balance it. You'd have to put 2 here, 2 nitrogens. That would make 6 hydrogens. And you'd have to put a 3 to balance that. Oops, jumped ahead too fast. So there would be a 3 there. So the next type of reaction we're talking about is decomposition. And decomposition, our analogy for decomposition is going to be divorce, which means to separate. You got one thing and you're separating it into 2 separate things. So that was synthesis, was combining to make something larger, and divorce is going to be taking things apart. So it's making a molecule into smaller molecules or atoms, taking something big and making it a little bit smaller. So we got our big item again here, and we're separating it into 2 smaller things. In general, we're going to say it's just AB separating into AB. A chemical example is we take water and we can actually turn it into hydrogen gas and oxygen gas. Again, this is not balanced, not because the hydrogens, because the oxygens. So we can only change the coefficients, which the number is in front there. So we are now balanced, and that's decomposition. Single displacement. Single means 1, displacement means to change, so we're changing just one thing. So normally this involves ionic compounds, which are, again, a cation and an anion, a metal and a non-metal, and one element kicks out one part of the compound. So the general equation is A plus BC equals B plus AC. So in this case, because A is written before C, we can say that A is a metal, because metals are always written first. B used to be with C, but along came A, and A is more attractive, kicks out B, and B is on its own now, and A is now with C. So an example of this would be magnesium plus silver nitrate equals silver plus magnesium nitrate. Who got to be in the compound here? Silver was with nitrate. But along came magnesium. Magnesium kicked out silver, and magnesium got to go with nitrate. I'm going to move my picture there so you can see it. So now we can see the nitrate, and the nitrate used to be with silver but is now with magnesium. This is why it's a single displacement. One thing is switching. Nitrate is always in a compound. Magnesium used to be on its own, now it's in a compound. And so they switch sort of, getting to go with nitrate. Here we have, and you can see it clearly, I've drawn out the chemical formula. We have nitrates, magnesium is now with a nitrate. Magnesium has a 2+ charge because it's group 2. Nitrate has 1 negative. If we look at this here, it's not balanced. Why? Because you have 2 NO3s here. That's what that bracket means. So we can't put a little 2 down here. We have to change the coefficient, and now we have 2 silvers. And if I look at it now, it's now balanced, and that's a single displacement. So it is an element and a compound. This is an element, 1 capital letter. This is a compound, 2 or more capital letters. and that's why it's a single displacement reaction. The fourth type of reaction we have is something known as a double displacement reaction. It's a reaction involving two compounds. They involve switching partners, okay? So you can see that I got barium sulfide plus potassium iodide. Let's take a look at that quickly. So barium sulfide, 2 plus 2 negative. I look, because this is 2 plus 2 negative, okay, plus potassium iodide. You can see that I have two capital letters here, two capital letters here. We know that the metals are positive, the non-metals are negative. What ends up happening is they're going to switch partners. The positive one goes with the other negative one. So positive always gets written first, the metals get written first. And this is what we have here, BaI2. And we have K plus S2 negative, K2S. So again, you have two things, so you have 2 and 2, and they are switching partners, so now you have two new partners, and that is an example of two things switching, so we call it double displacement. So two ionic compounds, and this is key. Single displacement and double displacement only happen for ionic compounds. And ionic compounds contain what? A metal and a non-metal, and you can clearly see the metal barium and potassium. Okay. That's it. That's double displacement. So I'll just give you the general equation here. AB plus CD equals CB and AD. What that means is A and C are both metals. How do I know that? Because they're written first in the order between the first capital letter and the second. So anybody who's written first is a metal. The last type of reaction is known as combustion, and is used by humans for energy when we burn hydrocarbons. It's their primary source of fuel in the world. Okay, so when we burn gasoline, we can use it for cars, but we also can use it to produce electricity, and this is why we have a problem with global warming. So there's plenty of different hydrocarbons that we burn. Now, what are the two elements that are found in hydrocarbons? Well, the answer is carbon and hydrogen. So the general word equation is a fuel, which we consider a hydrocarbon, plus oxygen makes carbon dioxide plus water and energy. So a general fuel, for example, this is methane. This is natural gas. It's natural because it's used when plant matter decays and things like that, but it's also found deep in the ground, and we can drill it up and use it to warm our houses. And when we burn it with oxygen, we produce carbon dioxide, water, and energy. And this is great because energy is good. We can use it for different things, but the problem is the more we do this, the more CO2 we make, and we contribute to something called the greenhouse effect. So carbon dioxide actually increases, it's a greenhouse gas, it increases the temperature on Earth, and over time it's made our Earth warmer and actually has caused some of these terrible weather effects like massive tornadoes, and not tornadoes, but more so hurricanes have been attributed to increases in greenhouse gases. And there's a lot of other detrimental effects that we're going to talk about in this class. Also, one of the things that can create is something called carbon monoxide, and you should have a detector in your home for this, because if your furnace, which burns natural gas, doesn't work appropriately, it will produce carbon monoxide, which can kill you. And so that's why it's really important that we have a carbon monoxide detector. Also, a lot of these fuels, these hydrocarbons that we dig up from the ground, they contain a lot of other chemicals that produce nasty chemicals that I haven't even mentioned here. They can cause things like acid rain and other detrimental or dangerous things that can happen in our world as a result of burning too much hydrocarbons. So this is the end of our show, and hope you had a good time, learned something, a thing or two, and we're going to answer a few questions now to make sure that you understand. Thanks.